Alright, so we're doing another lesson in Chapter 7 here, and that is strategies to integrate, things we can do to integrate. Most things can't be integrated algebraically. We have other methods, but we have some rules here for trig functions that are raised to powers. Now, sometimes we come up with a rule or a strategy to do something. Then when we see that, we try to use that strategy all the time, and sometimes it's not a good idea. So like in derivatives, when we have the quotient rule, sometimes when students see a quotient, they automatically use the quotient rule when sometimes you can rewrite it. We talked about the power of rewriting things. So if we have a monomial or a single term in the denominator, if we have a single term in the denominator of a rational expression, we can separate it and then handle each of those parts separately instead of using the quotient rule. So it's important to recognize when we should use a rule and when not to. So we have these rules that we're about to use, but there's an exception. If one of the powers if one of the trig functions is just raised to the first power, we probably could just use a simple substitution. So number one, example one there has an asterisk by it. So we see that cosine just is to the first power. So if we let u be the sine of 2x, and you think about what happens there, so then if we do du, take the derivative of both sides, we get cosine, and now hopefully it's pretty clear. Chain rule though, almost messed that up. Times 2. And there's no extra times 2 floating around out there, so we're going to have to divide that by 2. But the point is that cosine 2x dx is right there. So we can substitute that out, so it's a simple substitution. So this is going to be u to the 7th, and this becomes 1/2 du, so we put a half out there and du right here. And then that's nice. Okay, so if we add 1 to the exponent and divide by the new exponent, that would look something like that. Let's see. And then we can switch that back. So that's going to be sine to the 8th 2x. Alright. Now, look at this next one here. Sine is even and the cosine is odd. So look here, cosine is odd, that's number 2. So what does that say? That says save one cosine and convert the rest to sines. So if we take that cosine and we change it to cosine squared times cosine, and hopefully you realize why we're saving 1. We're saving 1 because that's going to be our du. So now we want to switch this to sines. So if you remember the Pythagorean identity, we could go up here. Cosine squared is going to be 1 minus sine squared. Cosine squared 1 minus sine squared. So we're going to switch that. It's 1 minus sine squared, and then cosine right there. Okay. Now, if we distribute that, that's going to be sine to the 6th minus sine to the 8th cosine x dx. Alright, so now if we let u be the sine of x, then du is going to be cosine. So we could write that down on the side, or maybe we're just okay with that. So u is going to be sine x, so du is cosine x dx. So this is going to be u to the 6th minus u to the 8th du. Right? So if we integrate that, that's going to be u to the, add 1 to the exponent, divide by the new exponent, add 1, oops. Plus c, and then substitute those back in, so that's going to be sine 7th alright. So then it asks us, how would example 2 be different if we had sine to the 7th power? So if you look at these two rules, that seems to be a little bit, which rule should you use if the sine is odd and the cosine is odd? But in that case, what you want to do is kind of focus on the smaller power, probably, especially if it's cubed, because it's going to be easier to break that one down than to break sine to the 7th down. So if you think about it, the difference would just be that the sine would be 1 more power, so it would have been 1 more. So it would have been 1/8 sine to the 8th power of x, and then this would have been 1 more also, so that would have been 1/10. So with them both odd, then you have to kind of make a choice. You're probably going to modify the smaller exponent. Okay. All right. So last one on this page, we have an odd power of sine. So it says if you have an odd power of sine, save one sign and convert the rest to cosines. So we're going to start with sine squared times sine, and we're going to convert that to cosine, so that's going to be 1 minus cosine squared sine. Okay, and that's the numerator, and then the denominator is cosine to the 1/2. So now this is essentially two terms. If I distribute the sign, I'm not going to, I'm going to go there, but so I can divide both of those by cosine. So that's going to be cosine to the -1/2 minus cosine to the 3/2, and then sine x dx. Okay, so if we let u be cosine, then du is going to be negative sine. So we need to be careful about that. That negative, there's no negative hanging around out there, so I need to divide both sides. So there's that substitution. Okay. So if we switch those out, this is going to be u to the negative 1/2 minus u to the 3/2, and then that is du. And notice that this is a definite integral, so we're going to need to substitute out those limits of integration as well. So the cosine of 0 is 1, and the cosine of pi over 2 is 0. Okay, so if we add 1 to the exponent here, this is going to be u to the 1/2. So divided by the new exponent, so divided by 1/2 times the reciprocal, and add 1 to the exponents, that's going to be 5/2, and then divide by the new exponents, that's going to be 2/5. Now, if you think about it here, we would need to switch these limits of integration, and when we switch those, we take the opposite, so that negative is going to become positive as we switch those. I'm going to switch them right here. Okay, so we switch the limits of integration. That makes it the opposite, but it was negative, so the opposite of negative is positive. Okay, if we plug 2 in there, we're going to get 2. I'll plug 1 in there, sorry. We're going to get 2. Plug 1 in there, we're going to get minus 2/5. And then plug in 0, you get 0 minus 0. So that's 10/5 minus 2/5. That is 8/5. Okay. Alright, so we have an odd power of sine here. So that's going to be 1 minus cosine squared to start. And then that's going to be cosine 1/2. And you might be saying, hey, hold on a second. Yeah, no, I'm going to put that down here. So then I still have 1 power of sine left over. So that is what we're going to do there. So now we're going to distribute this into that. So that's going to be cosine 1/2 5x minus cosine 5/2 5x and alright, so that's going to be our du. So we're going to let u be cosine. So du is going to be negative sine times chain rule. Okay, we don't have that negative 1/5 anywhere, so we have to divide by negative 5. There's our du. So I guess we could write it out. So that's going to be negative 1/5. I was thinking about skipping a step, but negative 1/5 u to the 1/2 minus u to the 5/2 du. So that's going to be negative 1/5. Now I'm going to go ahead and do the integral and then substitute it back in. So writing it out twice. So u to the 3/2, and then multiply or divide by the new exponent, so that'd be 2/3. So it'd be 2/3 u to the 3/2, but u is cosine. So So that would be cosine 3/2 5x. So just kind of putting it back in there. So that's going to be 7/2. So that's going to be minus 2/7. And then 7/2. Again, substituting that back in. Okay. Now, that's a little bit awkward, so we might want to get rid of these fractions inside here and just have, instead of having 3 fractions there, just have the 1 fraction out in front. So what we can do is the common denominator here is 21. So we can factor out 1 over 21. So it might look like this. So 21 times 5 is 105. And then if you think about 21 over 21 here, 21 over 3 is 7. So 7 times 2 is 14. And then here, 21 over 7 is 3. So that's going to be minus 6. Running out of room here. Okay. There you go. All right. So the third case, down here, would be if they're both even, excuse me, or if there's only one. So what we want to do there is try to get them down to powers of 2. So this would be the sine squared of 3 theta squared d theta. So the pattern on this is similar to the double angle formula. It's double the angle, half the coefficient to switch this. So that's going to be 1/2 1 minus cosine 6 theta in this case. And that's squared. So that the formula is 1/2 1 So this one, just to reiterate, was 1 minus cosine 6 theta. Okay. Now here we can square this out. So if we square that, that would be 1/4. And then this would be 1 minus 2 cosine 6 theta plus cosine squared 6 theta. And all of that would be d theta. Okay. Now what we should see here is we can do this again. Okay. Now it's both of these, sine squared and cosine squared, come down to a very similar format. They're both 1/2 and they're both 1 and cosine, and you double the angle, so that's going to be 12 theta. The difference is if it's cosine to cosine, it stays positive. And if it's sine to cosine, it's going to be negative. So that's on the front of the notes if you need to see that. So what is that going to do for us? So when we substitute that in place here, trying to save ourselves a little bit of work here, our writing, that's going to give us another 1/2. So 1/2 and 1 is 3/2. and then minus 2 cosine 6 theta, and then here we're going to have 1/2 cosine 12 theta. And all that's going to be d theta. Okay. So if we integrate that, that's going to give us an x there. So that'll be 3/8 x. And if we integrate this, now we could use a u substitution here, but hopefully if we think about that, we can just figure it out since we are kind of second-year calculus students here. So if we let u be 6 theta, then du would be 6 d theta, and then we'd have to divide by 1/6. So we're going to get that 1/6. I don't know, I'm kind of combining a few steps here. So we're going to get a 1/6 in front of this. We also have 1/4 times 2, so that's 1/2. So we're going to get 1/2 times 1/6. That's going to be 1/12. And then integrating cosine, we get sine. And then here, when we integrate this, we're going to get sine also, and then the u would be 12 theta, so that's going to be, the du would be 1/12, so that's 1/24, and then times 1/4 is 1/96. So that's going to be 1/96 sine 12 theta and plus c. Alright, so here we have cosine squared, that's an even power, so we're just going to split that up with the rule. So I'm going to have a bracket there, I think. One-half, and then cosine to cosine, it stays, it's positive, so that's going to be cosine of 2x Okay, so we can separate this out a little bit. So if we focus on this, that would be 1/2 x dx plus 1/2, and then that would have been distributed, so that would be x cosine 2x and that is a partial fraction. So that's where we're going to have, I don't remember the colors I used. So u is going to be x and du is going to be dx, and then dv is going to be the cosine of 2x, and so this side we integrate, this side we take the derivative, this side we integrate, so that's going to be sine 2x, and then again we would have the u situation where u is 2x, so then du would be 2 dx, and there's no 2, so we have to divide that out, so that would be 1/2. Okay, so remember we go like this. So how do we want to do this here? I don't know how much of that I want to do in one step. This we can integrate, add 1 to the exponent, divide by the new exponent, so that's going to be x squared, and then that'd be 1/2 x squared, so that's going to be 1/4 x squared on that part, and then plus 1/2, and in here, we're going to get this. So that's going to be 1/2 x sine 2x minus, and then we're going to get this. So that's going to be the integral. That's not a minus sign. So then we're going to get the 1/2 we can factor out here. And then we have the sine of 2x dx there. Okay, so 1/4 x squared plus 1/4 x sine 2x. And then we have 1/2 times negative 1/2, so that's going to be negative 1/4. And then if we take the integral of this, that's going to be cosine, but it's going to be negative. And then again with the 2x inside there, that's going to be a 1/2. So I'm skipping a lot of those u substitutions and hoping it's just kind of a clear thing. If u is 2x, then du is 2dx, and then dx is 1/2 du. So that's where these fractions come back in on these integrals sometimes. Okay, so our final answer here is that plus that. Negative times a negative is a positive. All right, so that's trig functions with powers.